Okay, so this example that I have here, okay, what kind of equation is this? No, it's not linear. It's quadratic, because what's the largest exponent you see? 2. So it's quadratic. So that's a quadratic equation. It would be linear if it was just x equals 16. But this is quadratic, x squared equals 16. I want you to notice this, that in this example here, the x term is not there, right? Do you see an x term? You see the x squared term, but you don't see the what? The x term. Okay. The example I did, you can easily tell me what the solution is. What number times itself is 16? 4 is a solution. Is there another one? Negative 4 is also a solution. Negative 4 times a negative 4 is a what? Positive 16. Okay? So you don't have to use a quadratic formula here. You don't have to use factoring here. Here's what you're going to do. Whenever the x term is missing, you're going to get the square part by itself first. So you see how x squared is on one side? And you're going to put the number on the other side, just like it is. Now remember, right now, what am I doing to x? Squaring it, right? I'm squaring it. What's the opposite of squaring? Square rooting. How many solutions do I have here? 2. What are they? 4 and a negative 4. Correct? All right, so watch carefully what I'm about to do. I'm just going to write it over. Okay, so to get x by itself, right now I'm squaring, right? The opposite of squaring is to do what? Square root. So I'm going to take the square root of both sides. What I do to one side, I do to the other. What's the square root of 16? Didn't we say that 4 was the solution? But how many are there? 2. Okay, so something else you got to remember. Some of you may not have gotten this far, but we did do this last semester. When you take the square root of both sides, you got to do a what? Plus or a minus. Plus or minus. The square and the square root undo each other, so you get x equal plus or minus what? No, 4. Those are your 2 solutions. Okay? Now, what I've just used is called the square root property. The square root property. The square root property. The square root property becomes handy if your quadratic equation is written in this form. Something squared equal a number. Something squared equal a number. Okay? So the square root property involves this idea. If u squared equals d, then that means that u is equal to what? Plus or minus, not d, but what? Square root of d. Okay? That's what the square root property says. So if you have something squared equal a number, then you're going to use what? Square root property. So here's how it looks. Number 1. Suppose I had this. X minus 5 squared equal 25. X minus 5 squared equal 25. What kind of equation is this? Quadratic. Don't square x minus 5 out, get that trinomial, bring the 5 over, then factor. You're spending too much time here. You're supposed to recognize, hey, in this problem here, in this quadratic formula, I can use what property right away? The square root property. Because it's in this form, something squared equal a what? Number. Something squared equal a number. And all I got to do is remember, all right, if I have something squared equal a number, I got to get rid of that squaring. How to get rid of squaring? Square root. So you're going to take the square root of both sides. Look, very simple. Watch. Square root. But you got to remember to do what here?
Plus or minus.
Plus or minus. You got to do plus or minus because remember you always get two solutions. Then the square and the square root undo each other. What's left on the left? X minus 5 equal plus or minus what? 5. All right, so that's where I'm at. We're almost done with this. So x minus 5 equals how many things? 2. So you're going to split it apart. You're going to say x minus 5 equals a what? 5. And x minus 5 equals a negative 5. And then notice I went from this quadratic equation to two what? Linear. So now I add 5 to both sides. What's one of my solutions? 10. Add 5 to both sides. What is the other solution? 0. And let's just check these two. Let's see why they work. Let's do 10 first. Go back to the original. What's 10 minus 5? And what's 5 squared? 25. Let's try 0. What's 0 minus 5? Negative 5. What's negative 5 times itself? 25. So those are your two solutions. Yes?
But if you had the same x minus 5 squared equals 45.
Then you would have to simplify the square root of 45. That 9 times 5.
I'm sure that's coming.
Yeah, it's coming.
Oh, I figured that's how I asked.
Yeah, I mean, I started out easy. I made this a perfect square.
Okay.
All right, but it's now always going to be a perfect square.
Yeah, that's right. It's going to get easy, guys.
Yeah. All right, so that's number 1. Let's look at another one. Okay, so number 2, listen carefully to this. X minus 5 squared equal 10. X minus 5 squared equal 10. So here's the idea. You see how, now I made this a point to where the left side were identical, x minus 5 squared, but then the numbers were not the same. One's a perfect square, the other is not, right? Okay, so notice what's going to happen. Okay, so let's do number 2. Given this on the test, you have to recognize that this is quadratic, but you also have to recognize, hey, I can solve this by using what method? Square root property. Because it's in the form something squared equal a number. So what's the next step I need to do? Take the square root of both sides. All right, so it only takes 2 seconds to do that. X minus 5 squared equal 10. So you're going to say square root with a what? Plus or minus. Then you have to remember that the square root and the square undo each other. They're inverses of each other. So x minus 5 equals plus or minus square root of 10. All right, so that's where I'm at. Now compare these two. Here I had x minus 5 equals plus or minus 5. Here I had x minus 5 equals plus or minus square root of 10. Last semester you talked about rational and irrational numbers. 5 is what kind of number? Rational. Square root of 10 is what kind of number? Irrational. So when it's rational, when you get to this point, when it's rational, you split it apart and you can tell me exactly what the two solutions are. When it's irrational, leave it like this. Just bring the 5 over. So you can say x equal what? 5 plus or minus square root of 10. But you do have to know that there are really how many solutions? 2. They are x equal 5 plus the square root of 10, and what's the other? Minus square root of 10. Those are your two solutions. All right. So notice that when you get to this point, you also got to recognize, hey, am I going to get rational solutions or am I going to get irrational? For us, since we're dealing with quadratics, if you have a square root left, it's irrational. If this was a perfect, see how this was a perfect square? The square root of 25 is what? 5. Do you see a square root? No. So it's going to be what kind of solution? Rational. So split it apart, leave it like this. I'm fine. Just know, though, on my math lab, you can't leave it like this. You have to say what on my math lab? 5 plus the square root of 10, comma, and then what? 5 minus the square root of 10, my math lab. Okay? Let's do one more with the square root property, and then we'll do some more tomorrow with it. All right, let's do that with the square root property. Let me make sure I'm doing one that's similar to your in-class worksheet. Okay, so let's look at this one. Number 3. 2x minus 1 squared equals a negative 16. 2x minus 1 squared equals a negative 16. You're going to use number 3. For the most part, it will look like number 3, the one that you're about to see. Okay, so what kind of equation is this? Quadratic. I'm going to ask you this question. Do you want to solve this by factoring, or do you want to solve this by using the square root property? Square root property. Much easier to use the square root property because it's already something squared equal a number. So all you got to do now to get rid of that squaring is to do what? Take the square root of both sides. Just like this, just like I'm doing. But don't forget, you got to say what here? Plus or minus. Okay. So the left side becomes what?
2x minus 1.
Minus 1. The right side becomes plus or minus what?
Minus 4i.
4i. Very good. Very good. 4i. Now, since that's not a rational number, here's the way I will accept it. Just like we did the plus and minus a while ago, this right here, you can do the same thing with this. Just bring the 1 over first, so you're going to say 2x equal what?
2x equals
1 plus or minus 4i, and then divide everything by what? By 2. Okay, so you get x equal 1 plus or minus 4i over 2. Now, leave it like that. Now, some of you are going to have this question, because some of you were doing this earlier. You're going to say, well, can I reduce the 4 into 2? No, because if you do this, and I saw this with some of you, let me just remind you about this. If you do this, the answer is incorrect now. Because it is not only 4i that's being divided by 2, but what else is being divided by 2? That 1. So no, you cannot do that. Now, I'm going to ask you this. What if I had this? Then could I reduce all of these? Yes. So that'll be 3, that'll be 2, and that'll be what? 1. Okay. So just notice the difference between the two. Some of you have a habit of doing that, and mathematically it's not correct anymore. Okay? All right. So leave your answer like this. Now, keep in mind, though, that on my math lab, you cannot write it like this. You have to, on my math lab is going to say, separate your solutions using commas. So you're going to say what?
1 plus 4i over 2.
Comma.
1 minus 4i over 2.
Right. Okay, that'll be my math lab. Okay? All right. So when you do this in-class worksheet, let me show you.